We are going to graph the curve y equals 2 sine of 1/2 x minus pi over 3 plus 1. The curve ultimately looks like this graph right here, and so let's take a look at how we got there. First thing we did is we had to decide what the parent function was. Looking at this trusty chart, we can tell that our parent function is y equals sine x because there's a positive coefficient of sine. And so we see that this is going to be our parent function. We're going to start on the axis of symmetry, go up to the maximum, down to the axis of symmetry, down to the minimum, and back up to the back up to the axis of symmetry. So, keeping that in mind, we're then going to take the following approach. After determining the parent function, we're going to determine the equation of the axis, then the amplitude and the phase shift. We're then going to determine the period, and then we're going to be able to state the coordinates of 5 points. We're then going to remember to properly scale the x and y axis, and right now we're doing question A. So, the first thing we do is, after deciding what our parent function is we say that the axis is at y equals 1. Now, how did we get that? Well, the axis is a horizontal line, and the y value of that horizontal line is given by the c value, which in this case is 1. That's the vertical displacement. The amplitude is always the absolute value of the a value, which in this case is 2. What that means is that our axis of symmetry will have a y value of 1, and then from there our maximum y value will be 2 above 1, and our minimum y value will be 2 below 1. And since the sine function starts on the axis of symmetry, then goes up, down, down, and up, we can tell that our 5 y values are going to be 1, up to 3, down to 1, down to -1, and back up to 1. So we already have the 5 y values of our 5 key points. We can then look at the phase shift. In this case, the phase shift is pi over 3 to the right. And we got that by looking at the argument. Now, we then have to determine what the period is. The period is 2 pi over 1/2. Now, how do we get that? Well, we know that the period is always 2 pi over k. Or excuse me, 2 pi over the absolute value of k. And in this case, the k value is 1/2. So the period is 2 pi over 1/2, which ultimately becomes 4 pi. Now we want to look for 5 key points, and so we're going to divide our curve, the horizontal length of our curve, into 4 equal-sized segments. And in doing that, we get 5 key points. See, here's our 5 key points, but they're divided into 4 equally long horizontal segments. So how long should each of those 4 equally long horizontal segments be? Since the whole period of it is 4 pi, divide that by 4, and we're going to get 4 equal length segments, each corresponding to pi radians on the x-axis. Since the first value given by the phase shift is pi over 3, we can then determine the next 4 x values by simply adding pi each time. So our second x value is 4 pi over 3, and then we have 7 pi over 3, 10 pi over 3, and 13 pi over 3. Meaning, using our original y values that we got on the previous page, the coordinates of our 5 points are given right there. Now, we then have to determine how to scale our x and y axis. Since our y axis is composed of pretty simple integer values, we're going to let our y axis have a scale of 1 for each vertical square. Our x-axis, though, is going to be pi over 3 radians for each horizontal square. The way that we get that in this question is by looking at the lowest common denominator. In this case, every denominator is 3. So our scale is going to be pi over 3 units. Doing that, we make our scale pi over 3 units, and our vertical scale is 1. We're then able to graph our 5 key points and draw an appropriate looking sine curve through them.